All right, let's talk about Rust. Specifically, let's talk about writing APIs that are so safe, they feel like they're from the future. Today, we're pulling back the curtain on one of Rust's most powerful and maybe one of its most misunderstood tools, PhantomData. We're about to turn those pesky runtime bugs into compile time impossibilities.
And you know, this quote, it just nails the whole Rust ethos, doesn't it? It's that feeling, halfway through a project, where you're both pulling your hair out, but also feeling kinda brilliant because you've built something so solid that the compiler itself just won't let you mess up.
Because we've all felt this pain. I mean, come on. You write code that seems perfectly fine, everything looks logical, but then at runtime, your program just falls apart. A panic, a crash, some totally weird behavior, all because you tried to do something in the wrong order. It's so frustrating, and deep down you know there should have been a way to prevent it. So, that's the boss fight, right? How do we level up from just putting up guards at runtime to check if things are okay? What we want is a bouncer, a compile time bouncer that stands at the door and says, "Nope, you're not even getting in." It stops the bad code from ever becoming a program.
And our bouncer, our secret weapon, is PhantomData. I know, it sounds a little spooky, like some ghost in the machine. But trust me, it's the key that unlocks this next level of safety. So, let's demystify this thing once and for all.
So what the heck is it? Well, in the simplest terms, PhantomData is an invisible marker that costs you absolutely nothing. It has zero size, it doesn't exist in your final program's memory. All it does is whisper to the compiler and say, "Hey, you see this generic type T? I know it doesn't look like I'm using it, but I want you to act like I am." It adds, as the source so perfectly puts it, vibes.
Without this little ghost, the compiler might get a little lazy. It might relax its famous safety checks because, from its perspective, that generic type isn't actually being used. PhantomData is basically you, looking the compiler in the eye and saying, "Trust me, bro, it's here, spiritually," and just like that, all the powerful ownership and lifetime checks snap back into place.
Okay, theory is one thing, but let's see this ghost in action. We're going to walk through 3 killer patterns where this shines, creating distinct states, branding IDs, and even enforcing permissions.
First up, ID branding. Look at the left. This is a disaster waiting to happen. A user ID and an order ID are both just numbers under the hood, so the compiler has no idea you shouldn't mix them. But now, look at the right. By using a phantom marker, we've branded them. They are now fundamentally different types. Try to pass a user ID to a function expecting an order ID? Bam! Compile error. The bug is dead before it was ever born.
And I absolutely love this analogy. Think of it like this. The underlying number, the raw U64 or whatever, that's the robot's body. It's identical for both IDs. But the PhantomData, that's the soul. We've put a different soul in each robot. And our compiler bouncer knows you can't just swap souls. They are now spiritually, and more importantly type-wise, incompatible.
Now let's level up again and talk about state machines. This is how we solve that socket problem from the very beginning. When you encode the state, like connected or disconnected, directly into the type, trying to call a function on the wrong state isn't just an error, it's an impossibility. The compiler basically looks at you and says, "Sorry, Chief, in the universe where this socket is disconnected, that send function doesn't even exist." And the way you build it is just so elegant. You create these simple empty structs to represent your states. You tag your main struct, the socket in this case, with PhantomData to hold that state. And then, here's the magic. You only implement methods for the specific states where they make sense. fnsend only exists on socket connected. It's not there for socket disconnected. Just like that, a whole class of bugs is just gone, wiped from existence.
Okay, now, before you run off and start putting PhantomData on everything in your codebase, a quick word of warning. This is a seriously powerful tool, but with great power comes the ability to make things, well, really confusing if you're not careful. Let's talk about the pitfalls.
The main thing is to be intentional. Think of it like salt. A little sprinkle where it's needed? Chef's kiss. But dump the whole container in and you've ruined the meal. Don't over-engineer. Also, keep an eye out for zero-sized types that have a drop implementation. That can get weird. And for the love of all that is holy, explain yourself.
A comment, a link, even a meme in the code can save your teammates from tearing their hair out.
So let's pull back and look at the big picture. This is more than just a clever coding pattern. This is about a fundamental shift in how you think about designing software. We're moving away from writing simple suggestions and into the realm of writing unbreakable laws.
You can really think of it as leveling up your API design skills. You start at level 1 with simple ID branding. Then you graduate to enforcing state transitions, like we saw with the socket. Level 3 is modeling complex permissions, ensuring a file opened as read-only can never, ever have a write method called on it. And then you reach level 4. Here, you're not just coding anymore. You're designing these ghostly, beautiful contracts that are enforced by the compiler itself.
So, to wrap it all up, PhantomData is this little type ghost with very real power. It's a safety net you give to the compiler, helping it do its job even better. It's a whole new design language you can use to bake constraints right into your API. And it does all this as a silent, spiritual guide, enforcing the law with absolutely zero cost when your code actually runs.
And I want to leave you with this final thought because it perfectly captures the shift in mindset. When you're using these patterns, you're not just writing code for other developers to use. You're crafting laws for the machine itself. Laws that will protect every developer, including your future self, from making simple yet catastrophic mistakes.
So the next time you sit down to build something, don't just think about the code. Think about the rules. Think about the system. And ask yourself this: what unbreakable laws will you design?